Hello students, today I will discuss about Millikan's oil droplet method to determine the charge of electron. The apparatus is as in the figure. It is a closed chamber having two plates. One is positive and other one is negative, connected with the source of electricity. In between the two plates, source of X-rays are attached, and on the opposite side a viewing microscope is attached. Above the plate, above the uh, uh, upper plate, atomizer, that is oil spray, atomizer of oil can be adjusted. Now when this atomizer sprays small oil droplets, the upper plate having a hole on it, it will allow the droplets to pass through it, and the droplets motion can be measured by the microscope, which will be ionized by the X-rays. From this From this we can determine the charge of the droplet, and hereby we can determine the charge of one electron by taking different values of their HCF. According to NCERT explanation, oil droplets in the form of mist produced by the atomizer were allowed to enter through a tiny hole in the upper plate of electrical condenser. The downward motion of these droplets was viewed through the telescope equipped with a micrometer eyepiece. By measuring the rate of fall of these droplets, Millikan was able to measure the mass of oil droplets. The air inside the chamber was ionized by passing a beam of X-ray through it. So X-ray is used to ionize the droplet. The electrical charge on this oil droplet was acquired by collisions with gaseous ions. The fall of these charged oil droplets can be retarded, accelerated, or made stationary depending upon the charge on the droplets and polarity and strength of the voltage applied to the plate. By carefully measuring the effect of electrical field strength on the motion of oil droplets, Millikan concluded that the magnitude of electrical charge Q on the droplet is always an integral multiple of the electrical charge E. That is Q equal to N into E, where N equal to 1, 2, 3, any number. Now, atomic models. From above experiments in the previous discussion, Dalton's indivisible atom is composed of subatomic particles carrying positive and negative charges. The major problems before the scientists after the discovery of subatomic particles were to account for the stability of atom, to compare the behavior of elements in terms of both physical and chemical properties, to explain the formation of different kinds of molecules by the combination of different atoms, and to understand the origin and nature of the characteristics of electromagnetic radiation absorbed or emitted by atoms. Now, properties of fundamental particles: electron, proton, and neutron. Symbol is given. Absolute charge for electron is negative 1.60276 into 10 to the power minus 19 coulomb. Proton positive plus 1.602176 into 10 to the power minus 19. Relative charge electron minus 1, proton plus 1. Mass of electron 9.109382 into 10 to the power minus 31 kg. Proton 1.6726216 into 10 to the power minus 27 kg, and mass of neutron is 1.674927 into 10 to the power minus 27 kg. The absolute charge of neutron is 0. The relative charge is also 0. Now, different atomic models are proposed to explain the distributions of the charged particles in an atom. Although some of these models were not able to explain the stability of atoms, two of these models, one proposed by Thomson and other Rutherford. First, Thomson's model. According to him, the electron is embedded into it in such a manner as to give the most stable electrostatic arrangement. Many different names are given to this model. For example, palm pudding model, resin pudding model, watermelon model. The model can be visualized as in the figure, positive charge embedded with electron. Now, an important feature of this model is that the mass of atom is assumed to be uniformly distributed over the atom. Although this model was able to explain the neutrality of the atom, but was not consistent with the results of later experiments, it cannot explain the distribution of electron, and hence it is discarded. After this, Rutherford nuclear model of atom was come near the scientists. Rutherford and his students bombarded very thin gold foil with alpha particles. Rutherford's famous alpha particle scattering experiment is, as in the figure, source of alpha particle, lead plate and photographic plate. In between the photographic plate, one thin gold foil was taken. When alpha particle is passed through the hole on lead plate, it makes a very small beam of alpha particle light, which will be scattered by this gold foil. The Rutherford scattering experiment can be better viewed by this model. Alpha particle, maximum of the alpha particle passes through the gold foil. Some are deflected in a small angle and very few are deflected back to the first medium. Rutherford drew the following conclusions from his experiment. Most of the space in the atom is empty as most of the alpha particle passed through the foil undeflected. A few positively charged alpha particles were deflected. The deflection must be due to enormous repulsive force showing that of positive charge of the atom, because alpha particles are also positively charged. Calculations of Rutherford showed that the volume occupied by the nucleus is negligibly small as compared to that of total volume of the atom. The radius of atom is about 10 to the power minus 10 meter, while that of nucleus is 10 to the power minus 15 meter. On the basis of the above observations and conclusions, Rutherford proposed the nuclear model of atom. According to this model, the positive charge and most of the mass of the atom was densely concentrated in extremely small nucleus, that is center of the atom. The nucleus is surrounded by electrons that move around the nucleus with a very high speed in circular path called orbits. Thus, Rutherford model of atom resembles the solar system, in which the nucleus plays the role of sun and the electrons that of revolving planet. Electrons and the nucleus are held together by electrostatic force of attraction. This is all about the two atomic models, Thomson and Rutherford. Rutherford atomic model has also some limitations. One, it cannot explain the stability of the atom, and it cannot explain the uh, experiments developed later on.